Alright, it's time for another math easy solution. Time to discuss further into the strategy for integration that I went over in my earlier videos. And now I'm going to go over basically examples 2 to 5. In my last video I did example 1. I'm going to go over 4 quick ones. Basically, to recap from my earlier video on the 4-step integration strategy that I covered, here's the 4 steps that I went over. Basically, the first step, simplify the integrand if possible. Number 2, look for an obvious substitution. Number 3, classify the integrand or the function inside the integral according to its form. And then number 4, it's always try again. And now in these following examples, I'll go over the process of selecting a method to use to integrate, but will not fully work out the integral. So now let's look at this example 2, integral of e to the power of square root of x. So now notice this is a radical. And like I showed in when we classified this, so as a radical, it's always good to use a substitution with a radical. So if we let u equals 2 square root of x right here, and now what we get here, what we could do is, is basically square both sides. This is the useful part of having this radical or the square root there. Equals to like this, so u squared, square both sides, equals to x. So we basically get rid of this this square root sign or this root sign. So now we take this derivative using implicit differentiation, so this becomes 2u du, and this equals to dx right there. So what we have these two, and now we could combine these together. This would equal now integral of e to the u. Now the dx is going to equal to 2u du. So we'll have a 2u, I'll put this better, 2u and then du. Yeah, I'll just move this 2 out of there. I'll put the 2 outside. So now what we have is, well, a u times by e power of u. And now again we could look at, well, classifying integrand. In this case, the integrand now is a product of u and a transcendental function eu, which is basically not a non-polynomial, and that's just basically what it is. And thus it can be integrated by parts. So whenever you have a multiplication of a polynomial like this, or a just one term or a power multiplied by another one like sine of x, e to the u, ln of x, etc., we could use integration by parts. So you could just use that and solve that. Yeah, so I'm not going to actually solve this one, just to show you that, well, once we get to this part, we could use integration by parts. And now we'll go to example 3, which is the integral of x to the power of 5 plus 1, all divided by x cubed minus 3x squared minus 10x dx. Now this one, I can't see any obvious substitution or algebraic simplification, so steps 1 and 2 don't apply. Those are the basically simplifying through substitution and algebra. And now, but the integrand, we know the integrand here is a rational function. So from step 3, we know that, well, it's a rational function. So we could just use the method of of partial fractions, not rational fractions. Just my mistake. But anyway, so basically we could use this, and so you could work that out through that method. Yeah, now once again, I'm not going to actually solve this, just to show you that that's what we're going to use. So now let's get to example 4. So we have dx over x ln x right here. Now the interesting part about this is we could use, well, step 2 in substitution, and the reason is because there's a ln x, and the derivative of ln x has a 1 over x, which is included in this integrand. So if we let, well, u equals to ln of x, du equals 2 1 over x dx, and now this whole thing occurs right here. So we could basically get rid of this that term there. So what we can get is we could plug this into here. So this would become this will just be, well, 1 over u, and then we'll have, well, a du, because we got rid of this right there, and we could just solve this easily. Yeah, now the interesting part about this, the integral of 1 over u, that's ln u, so you'll have a ln of x in the final answer. Yeah, and once again, I'm not going to write down the answer there, just to show you the method. And now the last example, example 5, finding the integral of square root 1 minus x all divided by 1 plus x right here. Now we notice that this is a radical, but using substitution for this would just make things more complicated, because the derivative is going to be really complicated, where you have this 1 over the 1 minus x all divided by 1 plus x, so that's going to use quotient rule, etc. So a good way to manipulate this, whenever you have a, let's say something like this, where you have very similar numerators and denominators, you can multiply the top and bottom by one of them, just so you could simplify and also cancel the square root. So what we could do is, well, let's write this down separately. Square root 1 minus x, square root 1 plus x. So now, because there's a 1 plus x right here, if we multiply it by, well, 1 minus x and a 1 minus x right here, this square roots cancel on the top, and also this, we can multiply this inside, and we could simplify this function. So this would equal the top 1 minus x, and now the bottom, we could put the square root inside. This will just be 1 plus x times 1 minus x, that's going to be 1. And then we'll have a 1 times x and a negative x times 1, which will cancel. So we'll have a next 1 minus x squared, then dx right here. And now we could actually just divide these out. So we'll have a 1 over, and I'll write these as two integrals right here. Then minus, this is going to be dx, minus right here, a x over square root 1 minus x squared dx. Now that we have this, recall from the table of integral formulas in my last video, and also my last video proof of this, this equals to, well, sine, this is just inverse sine of x, so that's what this integral is. And now this integral, we could use substitution to solve it, because again there's an x dx right here. So because there's an x dx and there's a 1 minus x squared, if we let u equals to, write a t better, let u equals to 1 minus x squared, we get basically a du equals to negative 2x dx. And again, in the substitution, you have an x dx, which matches this, and we could basically replace this all in there and solve the integral. So anyways, yeah, I'm not going to actually solve it, just to show you. But anyways, that's all for today. Hopefully you learn from this video and learn how to basically apply these 4 steps. And again, always, if you get stuck, just try again, try different substitutions, etc. Anyways, like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.